Good morning, everyone, and welcome to our thesis presentation. First of all, let me thank all of you for coming here today. A brief introduction about our topic. It is about prediction and forecasting for economic changes using machine learning for the real estate sector. I'm Menna, presenting alongside Fatima, Salma, Mohi, and Mohamed, supervised by Dr. Moustafa Youssef.
To walk you through the outline quickly. First, we're going to begin with the background and motivation behind our project, and then we're going to go through the two machine learning models and their data sets. And then we're going to go to the back end and front end demo. And finally, we will discuss the reinforcement outcome of our presentation.
Okay, so before we bore you with all the technical details, as researchers in the real estate industry, we want to ensure we're working smarter rather than harder to manage the customer base. Our motivation is simply trying to replace the complicated and hectic process of owning a property. BTech, our product, uses machine learning to produce the best fitting price and to make financially smarter decisions for the future by our forecasting tool.
Okay, so now we're going to move on to the machine learning models and their data sets. So the first model is the price prediction model, which estimates the current price of the properties entered on the web app.
So first of all, I'd like to give you a brief introduction or overview about our data set. We scrape our data set from the website AUC map. Here's a preview of it. The data contains the number of rooms, number of bathrooms, the finish type, the price of the property, the year built, the view, the area, the seller role, the payment method, the building type, and the address.
And among the data that we scraped from AUC map, we have over 41K entries and 18 columns. We have selected 10 columns to use in the model based on the feature importance, which we will discuss later on in the presentation. And among the 41K entries, we had about 9K duplicates, and some rows included missing values, such as the view or the published date. And we handled these missing values by replacing it by 0 or by the median, or by dropping the entire row, depending on the case. And here's an overview of the distribution of the prices. The prices that we enter in the model range from thousands of Egyptian pounds to 40 million, which covers the range of real estate prices in Egypt.
Okay, so we performed label encoding for the categorical values before passing them to the model. Label encoding is simply converting the labels into a numeric form in order to change them into machine-readable form. The columns that we did label encoding on were the address, the seller role, the building type, the finish type, the view, and the payment method. And this is how the data looks like after we perform the encoding.
Okay, so since we're dealing with a regression model, we had to go through the assumptions of linear regression, which include avoiding multicollinearity and having normality and having a constant variance. So this means that we can't have like an exact perfect relationship between two different columns in the data set. And we did the heat map for the data that's entering in our model. And as you can see, there is no perfect exact relationship between two different columns. And we also calculated the VIF score, which indicates if there's like a very good relationship between two variables. And as you can see here, the number of rooms and bathrooms and the area are the only columns that are highly correlated with the price, which is normal according to our research in the real estate sector.
So feature importance simply indicates how much the feature contributes to the model prediction. In relation, we needed to test our features in order to know the importance or the effect of each feature on the model. We concluded that the area of the house had the largest effect, followed by the neighborhood where the house resides, followed by the building type, whether it's an apartment, a twin house, etc.
And for the feature engineering, we extracted the age from the date that we scraped from AUC map, which is better understood by the model and helped us perform and obtain better accuracies. And here's a distribution of the ages that we obtained. We have most of the ages ranging from -8 to 0, which means that the buildings are yet to be delivered, and from 1 to 10 years.
We also worked on removing the outliers from the data set, since outliers cause various problems to the statistical analysis of the model and leads to bad prediction. For the area, for example, we dropped any outlier that negatively affected the model. For the number of rooms also, we dropped any outlier, we dropped any property which has more than 20 rooms. Same for the bathrooms between 0 and 10. And the age, we dropped properties built before 1942.
And here you can see that the scatter plot is affected by removing the outliers, and we zoomed in on 2 cells, and you can see that the data is distributed more equally, and the data points that were very far away were removed. And also for the residual diagram, the same thing happens. You can see it's a bit more zoomed in, and which performs better accuracies and numbers for our model. And here you can find the results. We used a few metrics to evaluate the model. We used the score, the average error, and the variance. And we trained 3 different kinds of models: XGBoost, Light GBM, and neural network. So XGBoost had a score of 0.89, Light GBM had a score of 0.77, and the neural network had a score of 0.42. And finally, we decided to move forward with the XGBoost since it performed better and had better numbers in our model.
Okay, so first, the XGBoost, we visualized the results using numerical results and graphs. Prediction is what the model predicted, and the target is our ground truth. For example, in the first entry, the model predicted the house to be 2.55 million, and the target value was 2.54, which makes sense based on our score. We also calculated the percentage error between the prediction and the target, which is 11.079%. The same thing also happened with the Light GBM. We visualized the same ways. In this model, the percentage was 13.02%, which is higher compared to the previous model. And finally, the MLP regressor or the neural network model 2, with a percentage lower than both the previous models, the XGBoost and the Light GBM model.
And now we're going to move forward to the next model, which is the price forecasting, where we use this model to predict future prices of real estate properties in Egypt.
This is a data set of our snippet for the second model, which predicts inflation. We collected our data from different sources to have more features in order to have better prediction. First, we have the date followed by the real estate increase or decrease, the economic inflation, the currency rate between the Egyptian pound and the US dollars, and the unemployment rate in Egypt.
Okay, so this data has 123 entries, and each entry represents a month, and the years are ranging from July 2012 to November 2022. And we have 2 sources for this data set. The first is Aqar Map, where we obtained the inflation in real estate prices. And the second is the official Central Bank of Egypt website, where we scraped the inflation in Egypt, the US dollars to Egyptian pounds currency rate, and the unemployment percentage in Egypt.
So while testing several time series models, such as Auto-ARIMA, Moving Average, LSTM, and others, we concluded that the best fitting model for multivariate data set was the profit model. Here's a prediction versus the ground truth from a snippet of our data presented in the first graph. The yellow line represents the ground truth, and the blue line represents our prediction. The second and third graphs represent estimates for the trend and monthly seasonality based on the training data. The second graph is the trend for a period of time starting June 2021 till October 2022. It shows an upward trend, which means the inflation was increasing over time at this time. And finally, the third graph represents the seasonality of data, which is the variation present at monthly intervals.
Okay, so this is how our second model works. First, the user picks a month and a year where he wants to predict the price of his property for. And then we run the model on, we create a range of dates, a monthly range, and we run the model on these different months, and then we sum the percentage of prediction and calculate the new forecasted price.
Okay, so moving on with our website. So following up with our system design, we deployed the backend using a Flask framework We also managed to integrate the model, and we used libraries including pandas and numpy. The database was using MySQL, and for the front end, we used HTML and CSS. So our website features include a sign-up page, login page, contact us, about us, price prediction, and price forecasting page. Okay. So as for our backend environment, we set up the environment using Python 3.10 and Flask 2.2. We also installed the Flask REST framework and the virtual environment to help build the RESTful APIs. We installed MySQL package to be able to store the user data. As for our database, we created just one table for the customer, which has the following fields: username, email, password, account type. An account type is a field needed by the model to know whether the user is a developer, an agent, or a property owner, and the subscription. And it's also important to note that we did not create a database for the dataset, as our model is running locally. As our backend APIs, all communication was done via both HTTP requests GET and POST. GET renders the HTML template, and POST is used in this case, for example, login. We take the username and password and validate it with the database. So our backend apps, we created several apps, each with a corresponding route, which includes the main page, dashboard, PD0, PD1, and so on. Those are all property details form, and about us, contact us, and so on. As for our model integration, both the price prediction and the forecasting model, they are both locally placed in the same directory as the APIs. The main libraries they use are the scikit-learn, pandas, and numpy. And how we integrated the model basically is through dividing the model into two main functions. One prepare model function, which trains the model on the data set beforehand. And then the run model. The run model basically takes user input from the front end and changes it to its corresponding encoding value. And the price or the forecasted price is then given back to the user.
Okay, now we're going to talk about the front end of our project, which was coded in HTML and CSS. This is the home page. As you can see, we have contact us, about, and login. And at the bottom of the page, you can sign up for a new account. This is the property details form where you enter the properties of the house so that you can predict the price in the end. This is the rest of the property form. There are a lot of parameters to enter to have a very accurate output. This is the dashboard. When you log in, you can choose whether you want to predict the price or forecast the price. And this is the demo. This is our homepage. This is the first thing that comes up when you open our website. As you can see, we have a few descriptions to show what our product can offer. Is maximizing your profit, reaping the benefits. And at the end of the page, you can sign up. You enter your email, username, password, and you sign up, and you go straight to the login page. Depending on the account type, also, there are different features, so you need to specify that. After signing up, you can log in. As mentioned before, when you log in, you can now choose whether you want to use the price prediction or the price forecast tool. We're going to choose price in this case. So the first thing we choose is the property we want to predict. In this case, we're going to try then we get to choose how many bedrooms or bathrooms the space has. This is how big the space is. Where is the property located based on neighborhood? And then finally, we have a few more extra things, features such as a garden or the view of the house, the type of finish, and the year built and the payment method. And before you get to see your price, you need to pick a payment plan. This is the price, the estimated price. Now we will show an example of the forecasting. You can go back to your dashboard at any time and select font. Here we choose the price of the property, the month we want forecast to, and the year we want forecast to. And this is the forecasted price. Thank you.
Moving on to the reinforcement outcome. For our reinforcement outcome, we decided to go with a commercialized product, which we call Baytech. We will explain the model, the business model briefly.
Okay, so we have two types of users. We have occasional users, which are basically the sellers and buyers, and we have frequent users, which are the real estate agents and the investors. So for our pricing and packages, we have three types of packages. The first is a one-time prediction, which is best for sellers. The second is a one-week limited subscription, which is best for buyers. And finally, the third is a monthly subscription, which is best for real estate agents and investors. How are we going to examine if our platform is working correctly? First, we will use the following KPIs. The first is the subscription numbers, the ratings, and the accuracy post-sale. And as you can see here, we have the vision and mission of our project. So we basically want to elevate the market of real estate in Egypt and have an accessible platform for with a cost-friendly and user-friendly, which is accessible to all.
So this marks the end of our thesis journey. We would like to thank the examination committee and our supervisor, Dr. Moustafa Youssef, for the tremendous effort and guidance and support he gave us.
And we will also like to thank our friends and family for their constant support. And that's it.